Welcome to part 2 of our video presentation on tutorial D devoted to Microsoft Excel Solver. In this part of our video presentation, we'll talk about the case that you need to analyze with the help of Microsoft Excel Solver. So the case involves a company called CV Fitness, and this company is manufacturing and selling various exercise equipment. So you can imagine yourself as being one of the operations or logistics managers for CV Fitness, and your job is to find like an optimal way to combine various shipments using trucks so that the overall cost of shipment is minimized for the company. So that's the overall objective. You're trying to minimize shipment cost, giving the kind of equipment and the kind of demand for this equipment at various stores that the company operates. So having explained like the main idea behind this case, let's talk about the details. Well, the first thing we're going to discuss the constant section. Some parameters that will remain constant. Well, in that case, they're not parameters; they're constants. So constant values are the things that are given for your case, meaning there's nothing you can do to change them, at least in the short run. So first of all, your company uses two types of transportation: trucks and tractor trailers. Each of those modes of transportation, each of these vehicles has a certain cubic feet characteristic. So in other words, if you're using a truck, the cargo capacity of this truck is 1,500 cubic feet. If you're using a tractor trailer, then the volume that one single tractor trailer can transport is 2,350 cubic feet. And all in all, you have 6 tractor trailers in your company and 12 trucks. Now, each of those vehicles has a different operating cost. It will cost you $1 per mile to use a truck to ship something, and it will cost you $1.3, $1.30 per mile to ship something using a tractor trailer. In other words, if you're loading a truck and you want to use this truck to ship ship cargo over 1,000 miles, then the operating cost per mile will be $1, and the total cost for this trip for the truck will be $1,000. And here you have operating cost per mile per cubic feet. This is obtained by dividing cost per mile by the cubic feet capacity of each of the vehicles. So in this particular case, it's not a formula, it's just like a value entered here, but you can very easily verify that those values are calculated by dividing operating cost per mile by the volume in cubic feet. So those are your shipment parameters in terms of the kind of volume and cost that you will have if you try to ship something using trucks or tractor trailers. Now, your company produces 3 types of exercise equipment: exercise bikes, or EB, and in order for you to ship one exercise bike, you need to have 12 cubic feet of cargo volume. So in other words, each exercise bike that you ship will occupy a certain area of a truck or a trailer tractor, and this is the area that is required for shipping one exercise bike. Then you have elliptical cross trainers, or CT. Now they need slightly larger space, which is 15 cubic feet. And also you have treadmills, and each treadmill requires 22 cubic feet of cargo space. So those are your constants. Now let's talk about the calculations part. Well, first of all, you're running your plant that manufactures exercise bikes, cross trainers, and treadmills in Memphis, Tennessee. And you produce your exercise equipment there, but then you ship this equipment to your stores, and you have a total of 5 stores located throughout the United States. First of all, you have a Philadelphia store, and this particular store is 1,010 miles away from your factory in Memphis. Then you have a store in Atlanta, in Miami, in Chicago, and Los Angeles. So each of those stores has a different distance from your plant in Memphis. Also here in the calculations and results section, you have store demand. So basically it's something that is given to you. You know that for this week, because this example, I believe, is formulated in terms of 1 week time frame, for this week you need to ship 140 exercise bikes to your Philadelphia store, 96 cross trainers to the Philadelphia store as well, and then 86 treadmills that have to be shipped to the Philadelphia store. So basically this is your demand. This is the demand that you need to meet. So let's say there are managers in each of those stores and they send you like a weekly demand forecast. They're saying for this week we need to have the following items delivered. So that's the case. Again, to repeat what we already said, the optimization problem here is that giving those constants, meaning giving these constraints about the amount of volume that each item has, also giving this distance between your plant in Memphis and your stores in various cities across the United States, and also giving the demand, and also giving the amount of cargo or the volume of cargo that trucks and trailers that you have in use can carry, how to minimize cost. And we'll talk about the calculations that lead to total cost in our second part. And this concludes part 2 of our video presentation on tutorial D, so thank you for listening.